Hello. Today I want to talk about dynamic baselines. So, what are dynamic baselines? Generally speaking, they consist of two components. The first component is in the name itself. It's dynamic. So what does that mean? That means that basically the baseline for a particular carbon project consists of data collected for the same year that the credits are being issued. So, carbon project gets issued carbon credits for the 2024. Data from 2024 is used to determine how many carbon credits that project should be issued with. So that's just what it means by dynamic. As the project progresses through time, data or information from that same period of time is used to issue the credits. Why is this important? Well, it's quite important because in the real world, things like deforestation rates and reforestation rates, they vary year to year. We can all think of a couple of big examples. So Brazil, for example, has been a roller coaster ride of deforestation. In the early 2000s, they were cutting down massive numbers of trees. More liberal governments came into office and their deforestation rates went down. Bolsonaro got voted into office a couple of years ago, and deforestation went way up because he's a very conservative president and he didn't really care about the environment. And then Bolsonaro got voted out of office, and currently the Brazilian president is Lula, and deforestation rates are going down again. Well, if you use historical data to describe what the deforestation rate is likely to be inside of a project, you could be misled there. Maybe you use historical data when Bolsonaro was in office, but since Lula is in office today, there's not as great a risk and there shouldn't be as many carbon credits issued. There's lots of drivers of these kinds of annual changes. I mean, the global pandemic was another big driver, and that didn't necessarily drive deforestation rates up or down in a predictable fashion, but it did change them in one place versus another. We're in 2025 right now, and Trump's tariffs seem to be like they're going to have a big impact on forest harvesting and deforestation rates. Forest harvesting in the United States might go up. Forest harvesting in the United States' old trading partners like Canada, maybe it'll go down. We don't really know. But if you're issuing carbon credits for some sort of forest conservation project, all of these things should be kind of accounted for. And again, this is kind of different than how it worked historically, because historically the way that baselines worked was that they looked at a bunch of data from before the project started, and they said, well, deforestation rates were doing this back then, therefore we think they're going to do something similar in the future. And obviously that led to, kind of some issues there. So that tackles the first component, which is the dynamic part of dynamic baselines. But I think that most dynamic baselines that I've seen have a second component to them, which is matching. So what do I mean by matching? The way that most of these baselines work is that they identify a set of areas outside of the project that you're looking at, use those areas as a control group, and follow the outcomes of those areas over time as an analog for what might have happened inside the project. So this is actually very similar to the idea of like a clinical trial for a drug treatment. When a clinical trial, does a trial on a drug, they take a group of people and they give them the drug, and in this case the drug is maybe forest conservation or reforestation, and then they take a group of people who aren't getting the drug and they follow the outcomes of that group of people. The difference between the two groups is generally thought of as the effectiveness of the drug. And in this case, when you're taking a set of matches outside of the project area and following their outcomes over time, the difference between those matches and what's observed inside the project is the basis for issuing carbon credits. This is a really good and kind of deeply scientific way of thinking about these things. And it differs from how we were doing it before, where people were kind of allowed to use either a series of simulations or a series of kind of predictive models to say what was likely to happen in the future. That's not necessarily the wrong way of doing it, but the risk there was that people were simulating or creating predictive models that were way too aggressive. And the nice thing about a dynamic baseline that uses matching is that, whatever happens in those matches, that's a real world outcome. If you identify 100 different people on the landscape who are similar to your project and 90% of them cut their trees down, then that's an outcome that you can really point to and say, like, this is something that's actually happening a lot on the landscape, and here's all the cases in which we've seen it happen. So those two components are what make up a dynamic baseline. And so putting them together, the way that you usually create a dynamic baseline is that you create a set of plots inside your carbon project, identify similar plots outside the carbon project, and follow the difference between those two over time. And each year you recalculate the numbers and you say, okay, in 2024, my control plots outside the project, 2% of them, for example, were deforested, or 5% of them were reforested and had trees planted on them. And based on that, you maybe would receive either, in one case, you might receive credits for 2% loss, or in another case, you might receive credits for 95% of the growth that you've observed. Okay, so that's kind of the fundamentals behind the concept. What else do you need to know about it? Well, there's a lot of considerations for dynamic baselines, and not all dynamic baselines are equal. One of the first considerations that you have to ask is how is the matching actually being done? Well, you have to find plots outside the project, and in doing so, you have to use a series of variables that you can say, like, make those plots similar to the project's own condition. So, for example, if you have a reforestation project, what you'd want to do is you'd want to find places outside of that reforestation project that are similar. Maybe they have similar slopes, maybe they have similar precipitation levels, similar distances to, urban areas. All of these are useful variables. So these are actually fairly common variables that people use. So that includes distances to urban areas, topographic information, climate information, precipitation information. If you're in the United States, you can use things like parcel information, or the land value is a really good one. Other good ones are maybe disturbance history. So, can we identify areas that had kind of a similar history to them, like a similar land use history, or were they harvested 20 years before, just like your project was? And then, of course, forest condition is one of the more important matching criteria. So you want to match large forest to large forest. You probably, if you're doing a reforestation project, you want to match young forest or bare earth to bare earth. And basically you want to do your best to kind of find a control group that is most similar to your project. Now, this can still go wrong, especially if you give a project developer too much leeway in how they create their own dynamic baseline. So, for example, Renoster looked at a project being developed under Vera's reforestation protocol recently, and we found that this project was taking place in an area that was pretty lush, pretty productive site to be planting trees. And sure enough, they put all their matches in an area that was much more arid. Now, Vera doesn't allow this on the surface. They require you to match to the same kind of ecoregion, but they were using really broad ecoregions to claim that this really arid area was a good match. The problem with this, of course, was that reforestation was much less likely to happen in arid areas, and so they were actually kind of reducing the penalty that they would have suffered from their reforestation process. One thing to note about dynamic baselines is that they can be used to measure either the chance that these trees were going to be cut down or the chance that these trees were going to be grown back on their own. And in fact, different protocols handle them differently. Vera's reforestation protocol, for example, is designed to determine whether or not the trees that you're planting could have been planted on their own for some other economic reasons. So, if you look at your dynamic matches, for example, and 5% of them are reforested without carbon credits, then that's maybe an indicator that there's a 5% chance that these trees could have been planted anyway. That would act as a penalty on the carbon project. So for whatever amount of carbon was sequestered by these trees, you'd probably have to reduce it by at least 5%. On the other hand, you can also look at the chance that these trees were going to be cut down. So in a big avoided deforestation project, for example, if 5% of your matches were deforested, then you could say, well, 5% of my project area might have been deforested. And in that case, that's how many credits you would issue, maybe 5%. For improved forest management projects, we actually combine both of those concepts. So IFM credits for both removals and for avoidance, and what you're trying to do with the dynamic baseline is assess what is the likelihood that these trees would have grown, and then maybe once they've gotten to a full-grown size, what's the likelihood that they would have been cut down. Aside from how the matching is done, the other important thing that you have to consider is how do you actually track the outcomes of the matches. So you've identified these 100 different areas outside your project to use as a control group. How do you actually determine what's happening in them? Well, there are good ways and bad ways proposed in the carbon markets, and this is broadly the term for this is called the stocking index. And if you use a good stocking index that's very correlated with biomass, you'll tend to get better results. So if you use a stocking index that itself measures biomass or forest carbon or something that really correlated like tree height, you'll get a baseline that's much more realistic, and you'll get a baseline that really tells you what's happening in those control plots. However, if you use a stocking index that's not well correlated, like for example, a spectral index that kind of just measures greenness, then you could end up in a situation where your baseline kind of confuses forest for agriculture, or your baseline doesn't really quantify how much carbon is accumulating or being lost inside your control group. So Pachama has actually done some excellent work kind of describing the influence of stocking index on dynamic baselines. It pays to use a good one, but the problem is that while we all agree that using a stocking index that measures carbon directly or measures tree height or something really correlated with carbon is the best way of measuring the outcomes in these control areas, there aren't global maps of carbon that we can use. I mean, the reality is that like scientists have not created global maps of carbon that are all that high a resolution that we can use for these things. Now, so the best solution for this tends to be like using third-party providers. And so, for example, Chloris Geospatial and Planet Labs both offer kind of third-party stocking index maps that measure carbon directly that are presumably more accurate than using something like the Normalized Differential Forest Index or one of these spectral indices. It's kind of unfortunate that there isn't like a public set of data because, you know, small project developers can't necessarily afford Chloris or Planet maps. But I guess that's kind of where we're at right now. Now, I wouldn't necessarily, I'm not necessarily endorsing either of these companies' maps. I wouldn't necessarily trust their carbon estimates for like small area estimation. But I do think that they are a reasonable way of saying what might be happening in a control group spread across a wide land. Of course, the more sophisticated carbon companies have their own stocking index models. So Pachama certainly does. Renoster has its own stocking index models. I think Carbon Direct also does, for example. And so, you know, we, of course, can use our own maps when it comes to creating these baselines. But again, that kind of puts small project developers at a bit of a disadvantage. So stocking index matters, and likewise, how you do your matching also matters. Another thing to consider with dynamic baselines, which I think that they were kind of criticized for a little bit in the early days, is that you won't get silviculturally realistic outcomes from them. What do I mean by that? Well, in reality, if you have some chunk of land, let's say in the United States, and it's going to be harvested, they are probably going to harvest all of it. You know, they're probably going to go in and harvest, like maybe do like a 2/3 overstory removal, and maybe you'll have like 1/3 of the biomass left. Well, if that happens, that's a fairly steep drop in carbon stock for a given year, and then it'll kind of recover, and then they would harvest it again, and it'll recover again. That's how harvesting usually works. But dynamic baselines, you'll never really get a dynamic baseline that simulates that kind of steep drop that you'd see from a harvest. The reason for that is that you're matching to a series of people outside of the project, and if maybe, let's say, 5% of them harvest their trees every year, then that's only like a 5% decline every year. So rather than having like this steep drop that's kind of realistic to you taking a bunch of trees out, you'll have kind of a shallow drop that kind of continues each year. This doesn't actually impact the credits like long term. I mean, you'll get the same amount of credits either way, but it doesn't look like the type of harvest that you would normally see on the landscape. So I guess like traditional foresters and stuff have sometimes kind of criticized this because like you're not actually getting some amount of credits that would really simulate what would happen if you cut those trees down that year. But what you do get is kind of a probabilistic estimate that kind of represents the probability of harvest on any given year. And that's kind of even better than just simulating a big clear cut that might have happened. Okay, so I think that covers most of what I wanted to talk about, but I figure why not go into a little bit more detail into the existing dynamic baselines on the carbon markets. Believe it or not, there are not that many dynamic baselines in the carbon markets that are officially approved. So let's talk about each of them, right? Vera's reforestation methodology is probably the most well-known dynamic baseline. So for their VM47, when they're planting trees, you have to have a dynamic baseline that finds matches outside of the project and sees how many of those trees would have grown back anyway. Isometric and the Ecosystem Restoration Standard have similar dynamic baselines for their reforestation methodology as well. On top of that, Vera's VM45 improved forest management methodology for small landowners also has a dynamic baseline. So that's an IFM protocol. And then the American Carbon Registry 2.1 protocol for large industrial private landowners in the US also has a dynamic baseline. To be clear, Vera's new RED Plus methodology, VM48, their consolidated framework, does not have a dynamic baseline. That is a baseline that is calculated based on historic deforestation rates, and that's certainly been a criticism that people have leveled at it, although I think that it's probably not a huge issue. They tend to look at a window of history that was fairly recent, and it's kind of, usually deforestation doesn't change that much, but it's still not an ideal. So let's just walk through these systems real quick. So for reforestation, for VM47, the way that works is you use remote sensing to identify plots inside your project and plots outside your project that are fairly similar. They have a set of matching criteria that they encourage you to use. You are supposed to find matches that have the same land cover and have the same eco-region, the same forest region, although, as I said before, we've identified projects that seem to not really be doing this very well. And then basically you follow the outcomes of those matches over time using a stocking index. So the stocking index could be something like NDFI, in which you're basically looking at forest cover in those matches. And for example, if you had 100 matches and 5% of them were reforested, then you might take a 5% deduction. Like I said, stocking index tends to be one of the more hotly disputed issues with this protocol. They allow you to use really wacky stocking indices that tend to be really confused with agriculture. So you could end up with a stocking index that confuses an agricultural field for a forest, and that's not great. The best projects will use a stocking index that is really tightly correlated with biomass.
Now, both Ecosystem Restoration Standard and Isometric do things a little bit differently. And one of the things that they do differently is that they do all the calculations for a project. This is unlike Vera, where a project developer does the calculations and then submits them. ERS and Isometric both do the calculations, and they settle on their own stocking indices, which are presumably, kind of more tamper-proof. And that's kind of why it's important that this happen, because we don't really want people kind of choosing where they place the points for the matches, and we don't really want people kind of picking a stocking index that gives them a more favorable outcome for their baselines.
Next, let's talk about Vera's IFM methodology, VM45. And rather than being remote sensing based, this is actually based on plots. So what it requires is for you to take a series of plots inside your project and then find plots outside the project that are taken by the government, and then follow those government plots over time as your analog. In the United States, the National Forest Inventory of the United States plots are used. The same can be said for projects in Europe and whatnot. This methodology is kind of only good in parts of the world that have a government inventory that is really good and being remeasured constantly. So that kind of only puts you in the developed and richest parts of the world if you want to use this methodology. That being said, I really like the idea of following plots. As we said before, with the stocking index thing, remote sensing can really easily be thrown off, and you can get weird numbers that way, and you can kind of bias the results. But matching to actual observed plots taken by a government is kind of reassuring. And I'm saying this as a company that does remote sensing with our dynamic baselines. One of the weird things about VM45 is that it handles growth and avoidance separately. And it's almost as if they have two different baselines. They have two different equations. On the one hand, for avoidance, they only look at plots that have experienced some sort of loss. And on the other hand, for removals, they only look at plots that have had some sort of gain. This is in contrast to just looking at the carbon stock of the plots themselves in average. but I do think that there's justification maybe for doing it this way. The last big dynamic baseline methodology that exists out there is the American Carbon Registry 2.1. And here is a methodology that I do have a problem with. The problem is that it only looks at loss. The way that this works is you have to identify properties in the region around you that are similar to the property that you're looking at, and then look at how much loss is occurring inside those properties as, you know, your baseline for what might have happened inside that project. Well, the problem here is that if you don't account for growth at all, then you could be enrolling a forest that's really young and was always likely to grow back anyway, and you're not going to properly account for that likelihood of regrowing. Well, you know, ACR's 2.1 methodology handles growth in a completely different way that I don't think is very sound. So I do think that a lot of people might be enrolling forests that are really young and getting credits for trees that were always going to grow back anyway. And their dynamic baseline only applies for the likelihood of loss, not the likelihood of growth. So it does go to show that you can set up these elaborate control groups, but you still have to measure as a counterfactual the same characteristic that you are trying to quantify. And in the case of an improved forest management project, you are trying to quantify not just the chance of loss, but also the chance of growth. So that's my big problem with ACR 2.1, and I don't think it's a very conservative methodology because of that. There's certainly other dynamic baseline methodologies out there. All of the other kind of third-party tech groups all have dynamic baselines, most of them based on remote sensing. Like I said, Renoster does. Carbon Direct, I think, does. You know, I think other ratings agencies like Calyx also have dynamic baselines. So this is a very common approach in the carbon industry at large, even though only like 4 or 5 methodologies have actually signed off on this kind of thing. I guess the other thing to note is that there are academics who kind of use the same kind of approach. So there was a big paper published from the NASA JEDI team last year that described the effectiveness of just conservation in general that used dynamic baselines. Thales West's paper, the ones that he used to kind of obliterate the REDD Plus carbon market claims, those also used kind of a modified version of a dynamic baseline in a sense, because they were based on matching to similar properties and following their outcomes over time. So it's an approach that is kind of gaining steam, and I hope it gains more steam in the carbon markets, because I think that it's deeply logical, and it approaches the problem of dealing with carbon credits in a very understandable and very similar way to how we approach hypothesis testing in science, in that you're creating a control group and measuring the differences in outcomes. So in summary, dynamic baselines are exciting, but not all the kinks are worked out, and people can certainly still manipulate them, so you should still do a little bit of homework even if a project is using a dynamic baseline.